Hey, what's up guys? Brian here with BPS Customs. Today we're going to be looking at the latest tiny powerhouse from motherboard manufacturer ASUS. This is the ROG Strix Z270i Gaming. So one of the biggest complaints that I had about the previous generation Z170 boards, and very specifically the Z170 Mini ITX options offered by the big motherboard manufacturers, is that there weren't really a lot of options that were color neutral in any way. A lot of the best boards had color accenting on them, even if it was minimal, like the Z170i Pro Gaming from ASUS, which is the precursor to this board, had red accents on it. Paul from Paul's Hardware actually did an excellent video where he was building a system that used orange components and he couldn't have these red highlights in it. So what he did was he actually had to disassemble the board and spray paint and otherwise color some of those red accents black in order to make everything match. While this is something that I guess some people enjoy doing, making the motherboard look exactly the way they want, it's a lot easier for the vast majority of builders to have options out there that will match with almost any system configuration, so that you're not stuck trying to use a board that may or may not fit with a system configuration that you already have set up. To that end, most motherboard manufacturers have now made this round of releases for the Z270 chipset almost entirely color neutral. And that is exactly the case with this board. And it's one of my favorite things about it is that it is a premium motherboard with premium components and almost every feature you could possibly want, even on a regular standard ATX motherboard, packed into this small frame that is color neutral and will match with any build. Now that's not to say that this is the only selling point for this board. There are so many features packed into this tiny footprint that it's probably going to be surprising for a lot of people who are used to have to making compromises when building a small system. I think first and foremost, the thing that impresses me most about this board is the way the power delivery and cooling on the VRMs is designed. These heat sinks are something that would be appropriate to put on a full-size or even extended ATX motherboard for cooling the VRMs. They're heavy and substantial and certainly would do a great job of cooling everything down. This will make it possible to achieve higher overclocks and greater stability. Another cool feature about this board is the inclusion of not one, but two M.2 slots. The first is on the front and includes ASUS's patent-pending double-decker heatsink, which actually sandwiches the M.2 drive in between a layer of thermal pads and is supposed to do a really good job of cooling down your M.2 drive, which can get pretty hot. Now, I haven't done any extensive testing on M.2 drives and their temperatures. I'll leave that to Steve with Gamers Nexus. He's got a lot more experience doing that kind of stuff than I do. But in theory, it looks like it would work pretty well. The second M.2 drive is actually located on the back of the motherboard, and this is actually a more traditional placement that motherboard manufacturers have been using on mini ITX boards for some time now. The fact that ASUS was able to squeeze one on the front as well is pretty astounding, actually. Now, up at the top left-hand corner of the board, you'll see kind of an unusual little port. This is actually a front panel USB 3.1 header. Now, this is something that some motherboard manufacturers are starting to put onto their higher-end products, and it's not something that a lot of case manufacturers have yet picked up on, but moving forward, it's going to become very important to have this functionality and accessibility on your case on the front panel, and ASUS is kind of getting ahead of the game here by putting it on this board. I think in the coming year, we're going to see a lot more cases start to offer USB 3.1 front panel connectivity. The rear panel I/O is also very fully featured. You'll find a display port, an HDMI port, Intel Gigabit LAN port, 4 USB 2, 3 USB 3.0 Type A, 1 USB 3.0 Type C, Wi-Fi antenna, and an audio bank including an optical output. Now, the audio bank is actually something that ASUS has been working pretty diligently on improving ever since the last generation of boards. At CES this year, I actually spoke with JJ from ASUS about this very thing. I expressed a little bit of skepticism, saying that it's hard for me as a consumer who doesn't always wear headphones and just relies on a standard 2.1 surround sound system for audio to differentiate between a lot of motherboard audio output. It seems like we've almost reached the point where, yeah, this is really good, and this board is also really good, and this board is also really good. And it's hard to really differentiate despite the fact that a lot of motherboard manufacturers are claiming that their audio solution is better for X or Y reason. JJ's response to that was actually to tell me exactly what ASUS is doing in their motherboard audio department to make things better. And a lot of that has to do with power delivery to headphones. And that may not sound like something that's super important, but the problem that a lot of headphone users face is that If you're using high-end cans, a lot of them need maybe a separate amp to power because they need to be driven by more current than regular motherboards can produce. The Supreme FX audio solution on the Z270i board features premium Nichicon caps, dual amplifiers, and a low dropout regulator for cleaner power delivery. This all adds up to a better experience for not only headphone users, but users of regular speakers like me. And it all is really incremental. You're going to see incremental changes generation over generation for your audio solutions that may not be readily apparent if you just compare two boards that are very similar in nature. But if you take this board and compare it to something that's a couple generations old, the differences in audio become very clear. A couple other things that I really like about this board is the positioning of the front panel USB 3.0 header. Now, this is not a huge deal for a lot of people, but I have built some systems where I've become extremely frustrated that the USB 3.0 header is positioned right above where the graphics card would go, which means that unless you want to drag your cable all the way across your motherboard from the front panel in order to plug it in, you have to route it underneath the graphics card and then up and under where it connects to the PCIe slot. This means that that cable can potentially become crushed or crimped, and it's a little bit of a hazardous condition if you're not very careful with what you're doing. This USB 3.0 header is actually right where it is on most ATX size motherboards, right at the edge next to the 24 pin. Right next to the USB 3.0 header, you also have a header for RGB LED strips. This is of course controlled by ASUS's rsync software and also is compatible with aftermarket brands like CableMod. This is actually not the only RGB feature of the board. There are RGB LED lights that shine down from the board onto the back wall of your case and create some nice accent lighting. So let's take this board, put it on our test bench, boot it up, and take a look at what the BIOS looks like and see what kind of overclock we could get. And we have safely landed in the BIOS. So this is ASUS's pretty standard UEFI. With every iteration of motherboard, every new chipset, they update it a little bit. You know, they introduce things like easy system tuning, they have monitors for your pumps and things of that nature, but for the most part, the look is the same. And I actually am a pretty big fan of the ASUS UEFI. I think it's very functional and very intuitive. But I don't do much in the easy mode. I tend to do most of my stuff in advanced. So if you swap over here, you start at the top with your favorites. I'm going to run through these menus and then we're going to try to do some overclocking. But your favorites is where you're going to see all the stuff that you use, I guess, the most often. But your main is basically the information about the board and the chip. Your AI tweaker is where your overclocking is generally done. This includes voltages down at the bottom, down here we go, and frequency at the top. Advanced, there's a lot of submenus in advanced, but basically this is like onboard stuff that you can change around. Anything that may be built into the board, like storage and network and things of that nature. This is where you change that and whatnot. This is your monitoring tab. This is where you see all your temperatures, your fan speeds, what the voltages actually are at the time. And then down at the bottom you have your Q fan. This is where you control your fan speeds. It's pretty easy. And if you don't happen to have, for some reason, a fan plugged into the CPU header, you'll need to disable fan monitoring, and this is where you do it. This is your boot configuration, boot priority. Shows you the drives you have configured. And then tool, easy flash. Yeah, this is where you could flash a new BIOS if you need it, or access any of your saved overclocking profiles and whatnot. All right, so we're back in the AI tweaker menu. This is where we do our overclocking. So we're going to try to hit the same overclock that we did with our Gigabyte Aorus board, which was 5.15 gigahertz. Now we did that at a pretty high voltage, and it would be nice to maybe drop that voltage down a little bit and see if we can get something stable at the same frequency. So let's try the same base clock and multiplier and see if we could achieve the same results. So we have to drop this down to manual in order to adjust our base clock. So the base clock that we hit that speed at was 103, and then the ratio, come on, the ratio was, geez, come on, man. The ratio No? It was 50. Ratio was 50. There we go. So this should give us a, there we go, right, it says it right up here, 5150 megahertz. So we did that at a voltage of 1.5, and that was pretty high. So let's see if we could get it stable. Let's say 1.38. Let's try this. And we're going to leave our memory at the stock profile. We're not going to change it into XMP because that sometimes messes with our overclock. So let's save changes and reset. All right, so we're in Windows, and we are not particularly worried that this looks like poo-poo right now because we haven't installed any of the drivers or anything like that. We just want to see if we are stable. Usually how I test stability is I let ASUS run for a while, and that will give us a pretty good idea, but we don't have time for that right now because this is not a 4-hour video. So we're gonna run Cinebench. All right, let's see if it works. Oh no, looks like that didn't work. So we're gonna try a little bit. Maybe we'll try, I know this chip can hit this frequency, so let me try a little bit higher voltage. And if that doesn't work, we'll take the frequency down. All right, so we're back in, go back to advanced, go back to AI tweaker, here we go. And let's scroll down to our voltage settings, and we're gonna try 1.45 volts. And we will save changes and exit. Okay, back into Windows. We're gonna give this another whirl. Go away, Steam. All right, well, it finished the test. So, you know, I'm not gonna call this 100% stable because like I said, have not done the ASUS burn-in test for any significant time at these settings. No, we're not gonna save these. So given what we've seen here, it looks like this board can hit the same frequency as the full-size Gigabyte Aorus board at a slightly lower voltage, which is really good news for anybody looking to pick this up and throw it in a mini ITX chassis, that's for sure. Granted, I do have some pretty beefy cooling on here right now. I have a full custom loop, but you know, at the same time, if you get any kind of reasonable facsimile of that, like, you know, an AIO or something along those lines, I think that you'd be fine. I think you could certainly hit some really good frequencies and be at least relatively stable. I don't think that I would run a 7700K at 5.15 gigahertz 24/7. I think that's just unnecessary. But having the ability to do that, it's nice to know that it's there if you need it, I guess. So are you guys as impressed with the performance of the Z270i as I was? I can fully admit I was not in any way expecting to achieve this kind of an overclock at this low voltage, especially with a board that is a mini ITX solution. ASUS has put some great engineering into the power delivery of this board, and it really shows. We were able to hit 5.15 gigahertz at 1.45 volts. Granted, not a great daily overclock, but something that is achievable for some people if they really need it. So that's it for this video, guys. Get subscribed to the channel if you're not already. Hit that like button down in the corner and hit that bell subscribe button down there as well so you get notified when new videos go live. Thanks for watching, and I will see you in the next one.